Do you ever wonder what robots have to say about climate change? In a fascinating conversation of Habits by Republica with Professor Francesco Doblas Reyes, head of nature science at the Supercomputing Center in Barcelona, we tried to understand how computers can not only predict the future, but help us build a safer one. I invite you to listen to the dialogue between my colleague Oana Igrișan, creator of the program Habits by Republica, with Professor Reyes on people, on robots, and the future of nature. Enjoy.
Professor Doblas, thank you for accepting our invitation to be here with us at Habits by Republica. I am very anxious to have this conversation with you, and I was looking forward for this, and I would like to find out together with our viewers how can supercomputing technology help us predict climate changes and how the world will look like. So my first question would be, can you give us an overview of your work and what are your main research areas, just to understand a bit the pictures and what are we talking about?
Okay, so nice to have this opportunity to talk to you and your audience. I work at the Barcelona Supercomputing Center, which is the national supercomputing center in Spain, and we host the largest computer in Spain for public research. It's also a research center in the sense that there are several departments that work on some of the key problems that society has in front of it. So we work on engineering problems, life sciences, computer sciences, with the development of hardware and software for supercomputing. And in my case, I lead the Earth Sciences department, where we work mainly on problems related to global air quality and climate. So we develop a climate model, among many other things, that we use to try to understand how climate works and how climate might evolve into the future. And for this, what we do is we have a computer program that needs to be run on a supercomputer for the reason that we are trying to reproduce the global climate. And for this, what we have is a part of the program that represents the evolution of the atmosphere with all the processes that we know are important, including the radiation, the evolution of clouds, and the evolution of the turbulence near the surface. Another part of the program analyzes and that reproduces what happens in the ocean with all the relevant processes again, like the behavior of salinity, the currents in the ocean, everything at the global scale. And we have other components of the program that look into the behavior of the land surface, the vegetation and the accumulation of water in the land, and the sea ice as well. And all those different components are interacting continuously. So we try to produce the climate evolution with this computing program, and all these different components are talking to each other to try to reproduce the continuous interaction between the ocean and the atmosphere, the ocean and the sea ice, the land surface and the atmosphere, and so on. The reason for needing a supercomputer is that the number of calculations that are required to represent all these processes at the global scale are enormous, and the data that are handled in those calculations, in the solution of those equations, is huge as well. So in our case, we use the supercomputer here, which is Mare Nostrum 4. It's the name of the machine, which hosts around 100,000 processors, similar to the ones you have in your laptop. And we need all those processors really to address the number of equations and that are necessary to solve, to understand not just the current climate, but also the climate between now and the end of the century.
I would advise our viewers to Google a bit the Supercomputing Center, because when we invited you, I did. So it's really impressive to see videos with how it looks. And about of how it looks, it's impressive what you do there. And I think I mean, the data have no emotions, but when you as people work with these data, I think it's impressive what you find out, and it's interesting how you can communicate what you find out from your data. And I want to ask you, how can data generated by this computer help in predicting climate change? I mean, how exactly is it done? I understand that, okay, you're just, it's like surveilling the sky, surveilling the oceans, I don't know. But, and why are they important in adapting and responding to climate change? Okay, so a part of what you find out, how can we use these data?
The important thing to take into account to start with is that climate change is happening now. It's a phenomenon that is occurring, and the last report from United Nations has two very clear messages. The first one is that the climate that we are living in now is more than 1 degree warmer at the global scale than the climate at the end of the 19th century. And the second message is that that warming is without any doubt due to the human activity. And this is the first time that a United Nations report is coming out with such a conclusive statement, in the sense that so far there was a lot of discussion about whether there were any doubts about the role of humans. There is no doubt whatsoever. And that this is accepted. The point now is that once we accept that our climate has changed and continues to change in a continuous way, the next question is, where do we go to from here? So what the climate is going to be like in 30 years time, in 70 years time, or 90 years time, into the 22nd century. And for this, the only tool that we have to extrapolate the current climate are climate models. So these are the models that I was referring to before, that need supercomputers to be run, and that perform a large number of experiments to take into account all the different sources of uncertainty that we know play a role in the provision of climate information. With all those simulations, what we do is we compare them with observations. We try to assign a certain level of uncertainty and confidence to all these different pieces of information, and then we transfer these simulations and the resulting information coming out of it to other researchers that are working on the impacts, the assessment of the impacts of climate change on different socioeconomic and ecosystemic sectors, in the impacts that it could have on urban climates, on human health, on the evolution of ecosystems in both the land and the ocean, in the economy itself. And at the same time, those simulations and results are used to try to understand how the different evolutions of the socioeconomic, the global socioeconomy can lead us to a warmer or a less warm climate at the end of the century. And somehow the other
Sorry, I would like to ask you something for our viewers, because we talk about climate change, and the picture is not so positive. But I would like to ask you something. The temperature will go up with 1 degree. What exactly does it mean for the environment? Because people might say, okay, it's 1 degree, it doesn't matter. But what does it mean for the environment? Let's tell people, what does it really mean? What's the impact of this 1 degree?
Okay, the impacts of 1 degree with respect to the climate that our grandparents actually experienced at 100 years ago means that, for instance, heat waves like the one that happened in July last year in southwestern Canada, where 600 people died, would have been impossible. So that was a heat wave in which in the northwestern US and southwestern Canada, temperatures of up to 50 degrees were experienced in regions that actually are relatively mild in summer. This means that that region was not prepared for that sort of heat wave. The consequences, apart from the death of a large number of people that is unacceptable, are that, for instance, forest fires were triggered immediately after the heat wave. It has been demonstrated that such a heat wave would have been impossible. It wouldn't have happened in a climate that was 1 degree warmer. So 1 degree doesn't, at the global scale, doesn't mean anything to a person in his or her daily life. But if we assume and accept that certain extreme events would be impossible, and the extreme events that we are experiencing now in a climate that was 1 degree cooler than what it is now, then we can't start realizing that it has an impact on our daily life. Such an event like the one we experienced, we saw in North America last year, would be feasible and plausible in Europe in the near future. We have to bear in mind that nowhere in Europe, any place has experienced 50 degrees of temperature. The highest temperatures were experienced in Sicily, in Greece, and in southern Spain and Portugal, and never reached 50 degrees. So we are talking of situations that have never been experienced, even in the area where we are, in places like Europe, where we have a very strong capacity to adapt to unprecedented events. So, and that means economic losses and basically human losses that are, as I said before, unacceptable. So, summarizing, an increase of 1 degree means that certain events that have an impact on humans, economy, and ecosystems, like heat waves, like forest fires that were unprecedented, like very strong unprecedented precipitation associated with fast storms, would be possible now when they weren't 100 years ago.
Yeah, so if we're not doing anything as humanity, so we're just living our lives and messing up with our lives and with the earth, in 10 years, how will this planet look like? If now we have already seeing the impact of climate changes.
In 10 years, it's not expected to be very different compared to what it is now. So possibly instead of 1.1 degrees with respect to the end of the 19th century in terms of global warming, it might be on 1.2 degrees. So that won't change essentially what we are experiencing now. The point is not that much whether we can do something for to change what the climate will look like in 10 years' time. The point is what we can do to stop the rate of increase of temperature in the next decades. So the important thing is that the temperature that will be reached in the planet at the end of the century depends on what we do now. So if we continue the emissions of greenhouse gases from anthropogenic activities, it means that it will have an accumulated effect, not just in 10 years' time, but also in 100 years' time and in the next few centuries. And as a consequence, some of the events, some of the phenomena that are associated with climates have already started a process of acceleration that won't be stopped, even if we reduce or even cancel out completely the emissions of anthropogenic greenhouse gases in the next few years. Those processes are, for instance, the melting of the land ice in Antarctica and in Greenland, and in the other ice masses over the continents around the world, or the acidification of the ocean, or even the increase of the CO2 in the atmosphere in terms of concentration. So somehow there are processes that will continue regardless of what we do for the next few centuries and even millennia, and that this will be purely due to the human action. What we can do for some of those processes, and also to reduce the level of warming at the global scale at the end of the century and beyond, is to slow down, to reduce the impacts, and to mitigate this warming and its effects that is already taking place. So what is in our hands is not really to stop it in the next 10 years and to go back to the climate that we were used to in a few decades ago, but to reduce and mitigate the impact and the growth of the global temperature and its regional effects.
So there are scientists that warn us that we are at a point of no return with climate. Nowadays, we're facing a war in Ukraine. We don't know what will happen, but what we know for sure is that Green Deal will slow down because of this. I don't really know if I want to find out the answer, but I'll ask the question: is it gonna cost us a lot, slowing down the Green Deal in terms of climate change?
Well, the climate change due to the human activity is a global problem. So it's not just a European problem. It's not just associated to the European activities. It requires a concerted effort at the global scale. So we know that Europe is a major emitter of anthropogenic greenhouse gases, but it's not the largest one. So it's well behind China and North America. That doesn't mean that we shouldn't make an effort, but even if the Europeans slow down its efforts to reduce emissions, it's probably not going to have a major impact in the short term. It will have an impact in the long term. However, the Green Deal has many different aspects. It's not just about reducing emissions. It's also about adapting to climate change. And there are many aspects of the adaptation to climate change that are not an option. So we really need to look at this into the face. So for instance, we know that Ukraine and Russia are big exporters of wheat and maize. And we know that with the war, this is going to be the war and the economic restrictions. This is going to be affected. So the global market of wheat and maize and other staples might be affected, and in particular the price of those staples. The preparation for the Green Deal means that not only we have to reduce emissions of CO2 and methane, but also that we have to be better prepared for the occurrence of extreme events that might have an effect on sectors like agriculture. So at this stage, when we know that there are geopolitical events that are affecting important things like the availability and the price of wheat and maize, what we need to know now is, are there any climate events that might affect the production of wheat and maize anywhere else in the world that might also affect the price and the availability of these staples? And this is the kind of things, the kind of problems that we are looking into at the BSc in Barcelona. It's not just looking into what the climate will look like at the end of the century in terms of global climate. Is what we can do now to help humanity to cope with events that are somehow co-acting with the Green Deal and with our preparation and adaptation to climate change. Because with more extreme events, the economic sectors that make us vulnerable will also be affected, apart from the geopolitical events that are taking place. And we need to be prepared for this. So we can't afford slowing down everything in the Green Deal.
Thank you, very interesting. But individuals will be impacted of everything which is going on in the world. But how can we as individuals act? What can we do For example, what can I do with my life to have a small impact? But if I'm doing, maybe my colleagues will do it. So what can we do as individuals to really have an impact?
Okay, there are three things that usually we as scientists have concluded that individuals can do, because we are individuals as well, and we have the same sort of questions for ourselves. The first one is not to feel guilty. So it's a global responsibility, but somehow what has happened so far, we had very little choice. So as individuals, it's important not to feel guilty and disconnect from the reality. The second thing that we can do is follow the recommendations from the governments and institutions that are suggesting ways to reduce our impact on the emissions in particular. There are many things that we can do and that we are doing. And for instance, the selection of rubbish at home, or driving less and using more public transport, particularly if it's electrified. There are lots of things that we are already doing as individuals, many of us, and that are actually making a difference, slowly, but making a difference. And the third one is, as individuals, we have, at least in democratic societies, the possibility of influencing politicians. We might have the impression that politicians have not changed concerning climate change in the last 20 or 30 years, but this is not true. So climate change is in the political agenda. It's probably not at the top, because it's one of these problems that is very long term, and for which the consequences can only be felt in many decades. But somehow it's there because people care about it. It's not just because of scientists, it's mainly because of people. So really following this and being aware that the politicians are listening, and that we as individuals can do something with our vote and with our participation in the political life of our countries, can also make a difference. So somehow I'm optimistic, and things might change slowly, but there are ways to do something.
So revolutions start at home. We can do little things and influence the politics. So this is enough for us to do, and I hope everybody will do it. What would you say to climate change skeptics?
Not much. There is a lot of information out there that illustrates the current knowledge about climate change and its causes, its impacts at the regional and local level. If people choose to be a skeptic about this, is a personal choice. It has to do with personal freedoms, and there is very little more to be done. So beyond the fact of laying out what science has already agreed that is behind this problem, and the making an effort to try to convey this information to those who might benefit most from it. So for instance, children, and going to schools and providing entry-level material for children of different ages to understand what is at stake here. I think we have to respect that some people might be skeptical about the issue, and it's a part of their freedoms. In any case, even if there are skeptics, it's obvious that climate is even if people think that there is no human influence in it, climate is changing anyway for natural reasons, and there is no reason, even if you're a skeptic, to avoid taking measures to reduce the impact of any natural climate variability that might be taking place. So reducing our vulnerability as humans to any climate evolution, be it natural or due to human influences, is a duty. And it has nothing to do with skepticism. It has to do with responsibility as societies to protect those that are the most vulnerable.
Yeah, so I hope that we will all be responsible in front of climate change. I would like to ask a question which was not agreed between us, but I would like, maybe maybe you don't have the answer. Maybe it's just I'm not a specialist. I'm just asking you because we here are obsessed with Chernobyl. And I was wondering if you, with the technology you have, can you predict if something wrong is going to happen there, where the cloud, the radioactive cloud, will go, like, just to put the population in, to warn the population, to do everything we can to save lives? Can you do it with your technology? Can you have any solutions to this?
There is this is not related to climate somehow. This is related more to air pollution and to the short-term events. So short-term in the sense that the spread is short-term. The consequences are very long-term. That's clear. But there are since the accident, the Chernobyl accident, and especially since the accident in Fukushima, many different warning systems have been put in place in Europe and in other continents to warn the populations in case of a radioactive accident. It could be radioactive, or it could be due to the release of chemicals into the atmosphere. So environmental hazards that can spread substances that can be harmful in the atmosphere. And there are several systems. We have one of them in Barcelona, but the European Commission has created a service under the umbrella of the Copernicus program, which is a program for the observation of the Earth, and it's a program that includes satellites for Earth observation for environmental purposes, but also services that are built on the images from those satellites and from models that take information from those satellites and try to predict the evolution of plumes in the atmosphere. So right now, the Europe is prepared to provide that kind of information in case an accident occurs, and this most likely that this will be coordinated at the European level through the Copernicus program, but at the national level, many of the countries in Spain, in Europe, and in particular in Spain, we are in charge of that capacity in our country. Will also have the facilities to provide that kind of information. But the situation is very different to what it was 36 years ago.
In 86, I think it was
86, yeah.
Professor Doblas, we were talking today very sensitive subjects, climate change and the war situation. And I have to confess that I feel better now after talking to you, because somehow you gave us hope that the situation is not that bad, and that we as individuals and as society can find ways to deal with it, and we together can do things to find a good solution for our planet. Thank you very much for accepting our invitation. It was a pleasure talking to you.
It was my pleasure as well to participate, and thanks very much.
Thank you.
Vă mulțumim că ne-ați urmărit, sperăm că v-a fost de folos și vă invităm în comunitatea noastră a Societății Omului Sănătos.